Assalamualaikum and hello everyone. Today our group will present about vector and Scala in military. So before we start our presentation, we want to introduce ourselves first. My name is Muhammad Haris Haikal bin Dahlan. My registration number is 01DTK22F1020. What is vector? Vector is a quantity or phenomenon that has two independent properties, magnitude and direction. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector and which an arrow indicating the direction. The direction of the vector is from its tails to its head. What is Scala? Scalars are used in mathematics and physics. The concepts used in physics are a stronger version of the same idea in mathematics. In mathematics, the meaning of scalar depends on its context. The word is either related to real number or a complex number or a rational number. In physics, a scalar is a quantity that can be explained by a number either without dimension or in a physical quantity.
So, what is the difference between a scalar and a vector? A scalar is a quantity with magnitude only. However, a vector is a quantity with a magnitude as well as direction. Also, a scalar has a number, magnitude, and a unit. Yet, a vector has a number, magnitude, direction, and a unit. Example: scalar and vector. Example for scalar: mass, length, distance, speed, power, energy, and work. However, for vector, displacement, velocity, acceleration, force, weight, friction, and momentum. Military usage. Cannon. Cannon is any piece of artillery that uses gunpowder or other usually explosive-based propellants to launch a projectile. Cannon vary in caliber, range, mobility, rate of fire, angle of fire, and firepower. Different forms of cannon combine and balance these attributes in varying degrees, depending on their intent used on the battlefield. Of course, for this we need vectors. It is used also in aircraft. The first documented installation of cannon on an aircraft was on the Voisin cannon in 1911, displayed at the Paris Explosion that year by World War I. All of the major powers were experimenting with aircraft-mounted cannon. However, their low rate of fire and great size and weight preclude any of them from being anything other than experimental.
I'm Shafiq and I'm also afraid, and my registration number is 01DTK22F1023. So in military usage, for tank ammunition, success and tank battle is often determined by the superiority of the weaponry involved. The increased reliability of modern tanks is due to the effectiveness of armor-piercing projectiles, such as that shown in Figure 1. Administrative research of armor penetrators. At the foundation of the research are mathematical models involving vector calculus. Formula vector and scalar are used first. Unit vector, vector u equals vector u per magnitude vector u. For second formula, we use cos delta equals vector a dot vector b per magnitude vector a multiply magnitude vector b. For third formula, use scalar product, which is vector a dot vector b equals a1 a2 plus b1 b2 plus c1 c2. For fourth formula, we use vector product. The vector product is vector a cross vector b equals matrix, and for first row it is a I j k second row A1, B1, C1, and third row A2, B2, and C2. For last formula is area of parallelogram ABC, which is in column in magnitude, vector AB cross vector BC.
So we're going to mathematical solution in vector and Scala. So we have 10 in point A. We want to shoot in point C. So we have vector AB 7i plus 3j minus 5k, and vector BC is 8i plus 5j minus 2k. We want to shoot to calculate vector AB cross vector BC, and in metric equal to in metric, and first row in I j k, and second row 7 3 minus 5, and third row 8 5 minus 2. And next equation we will look in first in I, we look in first column and first row. In the left here you took here, place in here, and multiply I minus in the second metric. We look here in second column as second column and first row on the left here, and we take you can metric and multiply j plus in third metric 7 3 8 5. We took from here from this, and on the left in here, and multiply k. And we'll in paragraph large bracket, and in small bracket 3 multiply negative 2 call it bracket minus small bracket negative 5 multiply 5 and equal to the 90, and minus we calculate in here, we come 26j, and calculate here we can 11k. Yes.
So, in conclusion, the applicability of elementary vector calculation operation in understanding modern tank munition from an engineer's perspective. And an engineer at the weapon technology directorate of the Army Research Laboratory design and test prototype projectiles use soft hypercade supercomputer facilities. A vector calculation repetition code into those computer simulation programs used to design and evaluation prison and process penetrator. Cadet and facility from United States Military Academy have in the research often in conjunction with the ARL scientific. The success of the future weapons development is contingent on the ability of the civilian and military research to effectively use mathematics tools. Then that's all from us. Thank you.